Welcome to the DIY Honda Garage channel. The DTC P0117 signifies an issue with the Engine Coolant Temperature, ECT, Sensor 1, specifically indicating that the circuit is experiencing low voltage conditions. This diagnostic trouble code is integral in that it affects the engine management system significantly. The ECT sensor plays a crucial role in managing engine performance by monitoring the temperature of the engine coolant, providing vital input to the powertrain control module, PCM. The proper functioning of this sensor is important for efficient engine operation, as it helps in regulating fuel injection and ignition timing. When the voltage reading is low, it implies potential sensor failure, short circuits, or issues related to wiring. Understanding this DTC is essential for ensuring that the vehicle operates without overheating or experiencing performance inefficiencies. The Engine Coolant Temperature, ECT Sensor 1, is primarily responsible for monitoring the temperature of the engine coolant, which ensures the engine runs at optimal operating temperatures. Its data is sent to the powertrain control module, PCM, influencing fuel delivery, ignition timing, and overall engine efficiency. The ECT sensor is located typically near the engine coolant outlet, making it accessible for inspection and replacement. As it gauges the coolant temperature, a malfunction in this sensor can disrupt the balance of air-fuel mixture, leading to poor combustion, increased emissions, and potential engine overheating. The low voltage condition identified by DTC P0117 suggests that either the sensor is malfunctioning or there is an issue within the wiring circuit connected to it. Hence, prompt troubleshooting is necessary to ascertain the actual fault and make appropriate repairs. Several possible causes can lead to the appearance of DTC P0117. First, a faulty ECT Sensor 1 could be directly responsible for the low voltage signal sent to the PCM. A sensor malfunction may arise from internal damage, wear, or exposure to extreme temperatures. Second, poor wiring connections could lead to insufficient or erratic voltage readings. Corroded connectors, loose terminals, or damaged wiring harnesses are potential issues in the circuit. Lastly, a short circuit in the wiring itself can also create low voltage readings. This might occur due to wiring insulation breakdown, exposure to heat, or mechanical abrasion. Each of these conditions should be thoroughly investigated during the troubleshooting process to pinpoint and rectify the underlying fault. When DTC P0117 is present, several symptoms may manifest, impacting vehicle operation and safety. An evident sign includes noticeable engine performance issues, such as rough idling, stalling, or lack of power during acceleration. In addition, the low voltage signals can potentially lead to increased emissions as the engine management system may incorrectly adjust the air-fuel mixture to compensate for erroneous temperature readings. Furthermore, a faulty ECT sensor can create a risk of engine overheating, as the system may not receive accurate temperature data to trigger fans or adjust fuel delivery appropriately. These symptoms not only affect drivability, but can lead to severe, long-term engine damage if left unchecked, making it all the more crucial for timely diagnostics and repairs. To start troubleshooting DTC P0117, the first step involves verifying the problem by turning the ignition switch to the on position, second position. At this stage, the Honda Diagnostic System, HDS, must be used to check critical parameters, including the ECT Sensor 1 voltage reading. The expected value should be less than 0.08 volts. If this condition is met, it indicates the failure has been replicated and you can proceed to the next steps in troubleshooting. However, if the voltage is above this threshold, it suggests an intermittent failure and indicates that the system might be functioning correctly at the moment. Therefore, checking for poor connections or loose terminals at both the ECT sensor and the PCM, powertrain control module, is essential before advancing to further diagnostics. For the second step in addressing DTC P0117, turn the ignition switch to the lock position to ensure safety. Next, disconnect the 2-pin connector from ECT sensor 1, enabling a more accurate voltage assessment without interference from the sensor. Once disconnected, turn the ignition switch back to on position 2, and again, use the Honda Diagnostic System, HDS, to check the ECT sensor voltage. The reading should still remain less than 0.08 volts. If the voltage reading aligns with this threshold, it indicates the sensor is not responsive when disconnecting. And the next logical step is to replace ECT sensor 1. However, if the voltage indicates otherwise, it suggests that the sensor is functioning correctly and no replacement is needed at this time. This process enhances precision in identifying the issue between sensor malfunction and circuit problems. The third troubleshooting step involves more intricate circuit checks, starting again with turning the ignition key to lock position. Following that, it's important to jump the SCS service check signal line using the HDS, which allows for advanced diagnostics on the circuit. Disconnect the PCM connector B49P as well to isolate the circuit. At this point, conduct a continuity test between designated test points, specifically between the ECT sensor 1 2P connector number 2 terminal, PNK pink wire, and the vehicle's body ground. The goal is to confirm whether there is continuity in the TW line, which connects the PCM to the ECT sensor. If continuity is detected, it indicates a short in the TW wire, necessitating repairs to restore normal operation. If no continuity is present, it suggests the TW wire itself is in good condition, leading to potential updates or changes to the PCM software requirements. After completing the repairs based on the earlier troubleshooting steps, it is crucial to proceed with final repair verification to ensure the DTC P0117 is resolved. Start this process by turning the ignition switch to the lock position and reconnecting all previously disconnected connectors, ensuring they are securely fastened to prevent future faults. Once everything is reconnected, turn the ignition switch to on position 2, readying the system for further diagnostics. Using the HDS, reset the PCM, powertrain control module, which allows the system to reconfigure its settings and adapt to the repairs made. After resetting the PCM, perform an idle learn procedure as necessary for engine tuning. Finally, check systematically for any confirmed or pending DTCs using the HDS to verify that the P0117 code has cleared and no other issues remain. Successfully treating this code confirms that the repair process was successful. To prevent future occurrences of DTC P0117 and to maintain optimal vehicle performance, implementing regular preventive maintenance measures is essential. Begin with a thorough inspection of the ECT sensor to catch any potential issues before they escalate into major faults. It is equally important to maintain the integrity of the wiring harness, ensuring that all connections are secure and that wiring is protected from heat and abrasion that can lead to short circuits. Further, keeping the PCM software up to date is an important part of maintaining engine management efficiency, as manufacturers may release updates that can rectify known bugs or improve sensor readings and performance. Documenting these preventive measures can significantly contribute to reducing the chances of DTC reoccurrence and extending the vehicle's lifespan. In conclusion, DTC P0117 indicates that there is a low voltage condition detected in the ECT sensor 1 circuit, which can negatively impact engine performance and efficiency. Proper diagnosis involves verifying the DTC using the HDS, assessing the sensor itself, and checking the wiring for faults or shorts. It is essential to follow the specified troubleshooting steps diligently to properly identify the root cause and effectively rectify the problem. Ensuring connectivity and integrity of both the ECT sensor and associated wiring is vital in maintaining a healthy engine environment. If further problems persist, keep in mind to execute the final repair verification thoroughly alongside preventive maintenance practices to safeguard against future issues. Awareness of these car diagnostic details is pivotal for Honda CRV 2011 to 2016 owners and technicians alike. Please like and subscribe to the channel. See you next time.